This video is a follow-up to our previous video about data types in Q. In that video, we went over all the data types available in Q and how to identify them using character, numeric, or symbol representation. Now we are ready to discuss another important topic in Q, typecasting. Typecasting refers to converting the underlying type of an atom from one type to another. How might you do that, you ask? Well, before we get to that, let's first answer why might we want to do this. There are many reasons to be aware of the types of data you are dealing with and why you might want to convert from one type to another. For example, most operators or functions expect their arguments to be of a certain type or types. If you multiply 2 of a character type by 2 of an integer type, you'll get a type error because the multiplication operator expects both arguments to be one of the numeric types. Let's see what I mean by that. So here our 2 is of character type, and then we're multiplying it by 2, which is of one of the numeric types. If we do that, we get an error, type error to be specific. Similarly, you might want to convert type of some columns in your table from strings to symbol to efficiently store the data on disk. These are just 2 common examples of why you might want to cast your data from one type to another. Now let's answer how you can typecast, and the answer is using the operator $. Dollar takes 2 arguments. On the left hand side is the desired type, and on the right hand side is the value of which you want to convert the underlying type. For example, to convert the type of 72.0 from float to an integer, we can run this command or this expression. As you can see, the result is of an integer type. Recall that there are 3 ways to represent data types: numeric, character, and symbol. All 3 of these can be used to pass desired type when using the $. Operator. For example, an integer can be represented as int, I, and 6. All the 3 following statements are equal. So we already ran the first one using the symbol representation. Then here's the numeric representation example, same answer. And then here's the character representation. Similarly, here's an example of converting a float to long. So using the symbol representation, using the numeric representation, and then using the character representation. All 3 of them give the same result. To create a symbol from a string, you can just use the backtick. So we have a string and we want to cast it to a symbol type. There you go. While these examples make common sense, some type conversions are not so straightforward. For example, if you convert a character to int, you will get back the position of that character in the ASCII code. You can find the position of different characters in the ASCII code on this website right here. For example, converting character R to int returns 114, which is right here. We can see lowercase r is 114. And converting 2 of character type to int surprisingly returns 50 instead of 2 of integer type. So that's because 2 here is represented by 50. Let's see these examples. So converting character r to int 114, and character 2 of character type to int will return 50. To avoid that, to get 2 of type integer, we can use the uppercase character representation. So instead of lowercase I, $2 of character type, you can use uppercase I, and that will give you the numeric output, in this case the integer output. You can also note that the right argument has to be a string. So if this argument here has to be a string for this to work. If you were to use a numerical type instead, you'll get a type error. So Here's an example of that. So make sure when you use a capital I, the right hand argument is of character type. You can also use built-in function value as well, like this. Value evaluates a list of characters as it would be evaluated if you were to type that content into the Q interpreter. So it basically ignores these quotations, and then you get back whatever the content is. So here we have 2. So if we were to run this directly into a Q interpreter, we would get too long. That's the default, and then we cast it to an int type, and that's what we get. This is a very powerful function, and we'll discuss that later in another video. Another useful function is string, which converts data type to a list of characters. So if you just give it some value and run the string function, you'll get a list of characters. So here you have string of 22. Now we'll discuss typecasting with temporal data types, which is very useful and can be used to extract specific information from temporal data types. For example, you can cast a date type to a month type to get the month from the date. So for our example, we're first going to assign the value of .z.p. Recall that .z.p gives us the current UTC timestamp in nanoseconds. We're going to assign its value to the variable a. So let's see what variable a is equal to right now. So here's our timestamp. Now, to extract date, which consisting of year, month, and day, here's what we would do. As you can see from here, we just pulled out the entire date part. To only get the year and month, only get the year, this is what we do. To only extract year and the month, we use month. Now, if you just wanted to get the month, here's the example for that. So you got November out. If you only wanted to get the date, which is 28th, you can do this. Now going to the timestamps, so right now the time it's showing is 4:27 and past 8 minutes. So to get the hour, we should get, you will use this example and it should return 4. There you go. To get the minutes, you do this, but here you're gonna get both the hour and the minute. There you go. To get just the minute, you would run this command. To get the hour, minute, and the seconds, just cast it to second. However, if you only want the seconds returned, so which in this case is 8, you can do this. Additionally, converting a date to int type gives us the number of days that have passed since the year 2000, January 1st. So in this example, we have a date type, and the date is January 5th, 2000. So if we convert it to an int, we get back 4 days. Similarly, if you were to convert a timestamp to long, it would give you the number of nanoseconds since midnight. So here's a timestamp with the nanoseconds precision, and if we convert that to long, we get a really long number. So that's all we have for typecasting right now. In this tutorial, you learned what typecasting is, different ways to cast one data type to another, and why typecasting is useful. As always, you can send me your feedback or suggestions at himanshu@enlistq.com. Please subscribe to our YouTube channel to stay up to speed with our latest videos and tutorials. Cheers!